Dear First Prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new lesson. Today, inshallah, we have a new lesson in the geometry. The lesson is Unit 4, Lesson 4, Part 2. Last time we have studied the parallelism, Part 1. We have studied if we have a straight line parallel to another straight line and a transversal intersect them, then we form an 8 angles divided into 3 relations, alternate angles, corresponding angles, and interior angles, and we solved many problems about this concept. Today, inshallah, we are going to continue the lesson. We have two main ideas. The first one, it's called talas theorem, and the second one is called the converse of the parallelism theorem. Let's start the lesson. Now, if we have this theorem called the talas theorem, okay, if we have many straight lines are parallel like this, okay, and the transversal intersect them, in which we have a condition that its segments between the straight lines are equal, yani this segment equal to this segment equal to this segment. Okay, what happened in this case? If we have another transversal, then this transversal will divide it in two segments. These segments are equal in length. This is the rule. Okay, again, if we have a straight line intersect many straight lines, many parallel straight lines, and the segments in between are equal, then if we have another transversal or another straight line intersect them, okay, its segments between the straight lines will be equal. For example, if the distance inside the straight lines equal 15 centimeters, then we will divide this 15 by 3 equal segments, okay, to be each one 5 centimeters like this. Again, if the distance between the straight lines equal 15 centimeters, then we are going to divide 15 by 3 because we have 3 segments equal 5 centimeters each, and we can write the theorem like this: if a parallel straight lines divide a straight line in two equal segments in length, then they divide any other straight line into equal segment. Again, if a parallel straight lines like this, straight line 1, 2, 3, and 4, divide a straight line, this one, into equal segments, okay, then they divide any other straight line like this one into equal segments. This is the first rule. Let's solve a problem on this one. In this example, complete under each figure using the given shown in the given figures. Okay, number 1, we have here AB, AD parallel to XY parallel to BC. Now we have parallel straight lines, and AX equal to BY. Then we have also equal segments. Okay, then since the two segments here are equal, then that means DY equal to YC. That means if YC equal to centimeters, then YD also equal to centimeters. Here he asked about dy, it equal to 2 centimeters. I think it's very easy. The next one, we have here AH, BY, CZ, DR are parallel lines, and we have here equal segments in between HO, OZ, and ZR. Okay, then we are going to divide this line AD into equal segments like this: AB equal to BY equal to BC equal to CD. Okay, here we have 12 centimeters. Then I'm going to divide 12 by 3. 12 by divided 3 equal 4. then this one equal 4, 4, and 4. Then AC equal what? AC here equal the distance from A to C equal 4 plus 4 equals 8 centimeters, and I think برضو it's very easy. Okay, the next one, here we have a for example AY parallel to OD parallel to NH parallel to BC. Okay, and we have AO equal to NO equal to NB equal segments. That mean AD equal to DH equal to HC. Since AD equal 5 centimeters, then we get that DH equal also 5 centimeters and HC equal also 5 centimeters. In that case, AC equals what? AC here equal 5 plus 5 plus 5 equals 15 centimeters. I think it's very, very easy. Let's solve the next example. Now we are going to solve this one with steps, okay, to show you how can you write steps in this case of problems. Okay, here we have in the opposite figure AO parallel to HD parallel to XY parallel to BC. It's clear here. Okay, and AD equal DX equal XB here. AD equal DX equal XB. Okay, and we have AC equals 18 centimeters. Find the length of AY. First, we are going to divide 18 by 3 because we have 3 equal segments. Okay, then we have 6 centimeters each. 6, 6, and 6. Okay, because they are equal in length. This one AH equal to this one, HY equal to this one, YC. Okay, now I need to write the steps. Of course, AY here, AY equals 6 plus 6 equal 12 centimeters. Now I need to write the steps. I will start with AH equal to HY equal to YC equals 18 divided by 3 equals 6 centimeters. That's because what? Because I will write the reason from here. Because AO parallel to HD parallel to YX parallel to CB, and this is the first reason, and AD equal to DX equal to XB. Okay, then now I write the reason. I wrote the reason. Okay, now I need to find the AY here equal 6 plus 6 equals 12 centimeters. Okay, the next one, and this one it's a revision on congruent, and we need to prove that AB parallel to CD. Let's learn how can we prove that two lines are parallel. Now we are going to learn when the lines are parallel and when they are not parallel. Okay, if we have a line like this and another line like this, okay, it's clear that the two lines here are not parallel. But why they are not parallel? Okay, if we have a transversal like this, and this angle between the first line and the transversal equal 40, and the line here equal, the angle here equal 70, now we get two lines, two angles in corresponding shape. This is a F shape, and they are not equal. Then that is the reason which makes the line are not parallel. Then the lines are not parallel. Let's see another different case. If we have a line like this and a line like this, now it's clear that the two lines are parallel. But why they are parallel? If we have a transversal like this and angle here equal 75 and its corresponding equal 75, now we have two corresponding angles and equal in measure. That makes the two lines are parallel. Then if two corresponding angles and not equal, that makes the line not parallel. And if we have two corresponding angles and equal, that makes the line parallel. Then the line we have here parallel lines because two corresponding angles have the same measure or equal in length. Okay, another case. This a line, and this is the second one. It's clear that the lines are not parallel. But why? They are not parallel because if we have a transversal like this and the first angle here equal 60 and its alternate angle equal 20, we have here alternate angles and not equal. That makes the two lines not parallel. Okay, another one or another case. If we have line like this and another line like this, we have here two lines are parallel. Okay, it's clear that they are parallel. But why? Why? Because if we have angle like this and its alternate like this equal to it, then we have two alternate and equal angles. That makes the lines are parallel to each other because two alternate angles are equal in measure. Then the lines are parallel because two alternate angles are equal in measure or have the same measure. Then if two alternate angles are not equal, that makes the line not parallel, the lines not parallel. And if two alternate angles are equal, that makes the line are equal, then that makes the lines are parallel to each other. The third case with us, the first line like this and this is the second line, they are not parallel. Why? Because if we have a transversal connect between them, makes two angles, the first equal 80 for example, the second equal 100, and this is wrong because this angle must be more than 100. Now it's correct. Here we have 80-degree angles and here we have 120. The sum here 120 plus 80, it's equal to 200 degrees. It's not equal to 180. That makes the lines, okay, are not parallel. Why? Because two interior angles and not supplementary. Okay, then the lines are not parallel. But in the opposite case, if we have a line like this and another line like this, it's clear here that they are parallel. But why? Because if we have a transversal and two interior angles, one of them 80 and the other 100, then the sum of them equal 180. That makes them supplementary. Okay, that makes the two lines are parallel. Why? Because two interior angles are supplementary. Finally, two corresponding angles not equal, then the line not parallel. Two corresponding angles equal makes the line parallel. Two alternate not equal makes the lines not parallel. Two alternate and equal makes the lines parallel. Two interior not supplementary makes the lines not parallel. Two interior supplementary makes the lines are parallel. Okay, and this is the end of the rule. Let's solve problems on it. In this example, AD BD intersect AC equal M. Again, BD intersect AC at M, that makes two vertically opposite angles, remember with me, and MB equal to MD, MB equal to MD, MA equal to MC. First, is triangle AMB congruent to triangle CMD and Y? Okay, let's solve this one. First, here we have BM equal to DM and AM equal to CM, and the angle M here equal to angle M here, okay, VOA. Then we have two lines and the included angles, two sides and the included angle, and here we have two sides and included angles. Then the two triangles are congruent. Then triangle AMB is congruent to triangle CMD because, okay, number one, AM congruent to CM. Number two, BM congruent to DM. Number three, angle AMB congruent to angle CMD. Don't forget to write VOA. Okay, and the case here is SAS. Okay, then the two triangles are parallel, are congruent. Okay, now we need to prove why AB parallel to CD. AB parallel to CD. In that case, since the two triangles are congruent, then measure of angle A equal to measure of angle C. And here angle A and C form alternate angles like this. Alternate angles, which makes the lines AB parallel to the line CD. Now I'm going to write the reason. AB is parallel to CD because measure of angle A equal to measure of angle C, and of course they are alternate angles. Okay, let's solve the next one. Here in this example, example 4, AD is parallel to BC, AD parallel to BC, and E belongs to BC, like as we see. Okay, E here belongs to BC. Measure of angle B equals 75, AD equals 125. Okay, and the measure of angle DCF here equals 50 degrees. Okay, first, is the triangle AB parallel to CF, sorry, is AB parallel to CF and Y. Okay, here first we have AD parallel to BC, and the transversal CD makes a Z letter as you see. Okay, then we can reflect 120 from D to C, then angle C, the whole of angle C here equals 125 degrees. 125 degrees. Okay, then to count this one, it's easy. 125 minus 50 equals 75 degrees. Then this angle equal 75 degrees. Okay, again, since AD and BC are parallel and this is a transversal makes Z shape, that makes angle D and angle C equal in measure. Okay, angle C, the whole of angle C equals 125, then 125 minus 50 equals 75 to get this angle. Okay, now we have angle FCE here equals 75. It's equal to angle B, and they are what? They are corresponding angles, as we see here. If we highlight at AB like this and highlight at FC like this, and the transversal here makes letter F as you see, then we have two corresponding angles and equal, that makes AB and FC equal in measure. Okay, we are going to write this one, okay, in two steps. In the first step, we are going to find the angle 125 and 75 like this. Measure of angle DCE equal to measure of angle D equals 125, and they are alternate. Okay, that's because AD parallel to BE or BC, and this is clear here. Okay, now the second step, measure of angle. This angle is called FCE. FCE equal 125 minus 50 equals 75 degrees. Okay, finally we get that FC parallel to AB. That's because measure of angle FCE, this one, equal to measure of angle B. And they are corresponding angles. Now I wrote abbreviation for the word corresponding. Okay, let's solve the next example. Okay, this was the last one. Okay, this is the end of the lesson. I hope it was helpful for you. See you in the next time, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.